All right. Hello and welcome to everybody who is getting joined in. We went ahead and started the call here just a few seconds early, and it's probably a good thing because I'm noticing that it's taking a little while for Zoom to let people in. So now I'm seeing people come through. So again, hello and welcome. What I was saying before you got here was that we started the call a few seconds early because we know that Zoom might take a little while to let people in, and that's exactly what it did today. So luckily, you haven't missed anything. We just got started. And we'll start by first saying thank you for being here. One, we know it's a lot to pull yourself away from the counter or out of the field to spend a little bit of time with us. So, our goal here today is obviously we're going to talk about electronic throttle bodies, but we're going to try to condense this into about 30 minutes to give you the highlights, all the information you need. That way, you can go out and have some great conversations around electronic throttle bodies. So, with that, what are we going to talk about? So, there's a few things. We're going to discuss what they do, very high level, but I think it's important to understand what they do and why. Also, why they fail. We're going to go over a couple of technical tips that will not only help your technicians in the shops, but even your DIY customers, maybe avoid a defect or even avoid having to buy an electronic throttle body in the first place. And then we're going to talk about some of the engineering improvements we've done at BWD to make sure that when we hand that throttle body to the technician, they have confidence that it's not going to fail in the same way that the original did. And we'll talk about that. And then I'm going to pass this over to Miss Reese, and she's going to go over some of the competitive landscape that we have. And I think you're going to be excited about that because that's going to give you an idea of where you stack up against the competition as a result of where we stack up against the competition. And I can tell you now, nobody's got us beat. And Reese is going to go through that with you. And it's going to be a nice little conversation. And then, we'll wrap up at the end with a nice synopsis of what the program looks like and how you can use that as sales support when you're out there in the field, the talking points, the things that you can use as a great way to start conversations around electronic throttle bodies. So with that, let's talk about what they do. Well, an electronic throttle body is really just the replacement of a throttle cable. We always had the throttle body, right? We had that and a cable. The problem with the cable is the cable can get slack in it, it can break, and it has that ability to be feathered by the foot, which means we're not going to get consistent fuel trims. We're not going to get consistent information going to the PCM. We're really just wide open taking that throttle body, opening it or closing it with a cable, and it's not very efficient. You're not going to get the full range of power. You're also not going to get the correct fuel economy out of the vehicle if that cable has any deviation. So many years ago, they went to what's called drive-by-wire. And drive-by-wire, I hear that, I still think cable, but really what it means, drive-by-wire, is electrical wire, meaning sensors and pigtails. And so the way the throttle body works now is the exact same way that it worked before with a cable. The difference being there is a multitude of information and sensors monitored and giving communication to the ECU so that everything can work together. So what happens is the driver puts their foot on the accelerator pedal, right? And then the position sensor of the pedal gets that command from the driver, sends that command to the ECU, and the ECU now knows the amount of demand that's coming from the driver. So we have a command coming from the driver, but that's telling the ECU how much demand we need. Are we going to want to go fast, or are we just kind of cruising off of a red light? When it gets that information, it's then going to open the throttle blade based on the command from the driver. But at the same time, it's also going to be reading and calculating fuel delivery, spark timing, cam timing. It's going to be reading that mass airflow temperature. It's going to be reading NOx sensors and a various multitude of other sensors so that everything works together. We get much better fuel economy and we get much better performance. And so there's a lot of things that are in play here. If you look at the bottom right-hand side, we even have an ABS control module down there. Well, why in the world would we have an ABS control module in the frame here when we're talking about electronic throttle bodies? Well, the reality is whether we're pressing down on the pedal or we're releasing from the pedal, we're sending so much data to that ECU, it's now communicating again with everything, fuel, spark, timing, as well as ABS systems, because it knows we're letting off of that throttle. So there's a lot of things going on. So essentially what the electronic throttle body does is it reads a lot, or actually The throttle body is commanded by the ECU. The ECU is doing really a lot of the work. It's reading everything and telling the throttle body what to do, but the throttle body is still doing what it used to. It opens and closes based on the demand coming from the command of the driver's foot. It's just the ECU's doing the work now. And so again, it's going to use all that data from that pedal position sensor, the mass airflow, the NOx sensors, and a lot of other things to understand exactly what the driver is asking for. And at that time, it's then going to adjust the throttle blade position and the fuel delivery and spark all at once. Now, all of that's happening to do really one thing: spin this little two-way electric motor to open and or close the throttle blade. So you got all these things going on for something pretty simple here. And there's a lot of ways that can go wrong because of the amount of sensors. But the reality is, if everything is reading correctly, we shouldn't have any issues with the throttle body. But there are some things that can cause them to fail. We're going to talk about those here in just a minute. But again, that's what the throttle body does. It opens and closes, brings air in, and closes off so air can't get in again if we don't need that demand. That's what it does. So why do they fail? Well, we call it an electronic throttle body, but the reality is it still has a lot of mechanical components in it, right? We have to have something that turns that motor. We have to have some actuation. And the problem is these are sealed units. So there's no oil, there's no lubrication, there's no way to service the internal components of these electronic throttle bodies. So after millions of times of being cycled, harsh conditions, cold, hot, so many miles, they can fail internally because I'd say the vast majority of ETBs in the OE side of things are going to try and reduce the cost by using plastic gears or plastic gearing and components within the inside of the throttle body. We use that word as a distinction, plastic, because this is not an event or a scenario where we want plastic dealing with this amount of torque. So what you see here on the screen is an OE electronic throttle body with all plastic gear train. You'll see why here in a minute. That's not a good idea. We also have to keep in mind that the geometry of the gear train is important as well. So the materials matter, but also the geometry. If the geometry is wrong, these gears will not line up as well as they should, and it will cause premature failure because either there's not enough width or the teeth don't line up the way they're supposed to. So we'll show you how we corrected that as well. So these are the main reasons they fail on this next slide here. So the most common is going to be carbon buildup on the throttle blade. Here's what you have to know. No matter how well you maintain your vehicle, with today's cars, with the fuel that we use and the oil that we burn, it's so thin, we're going to have carbon buildup. It's going to happen. It's okay. It happens to everybody's throttle body. You can usually clean that off. The most important thing to note is you have to clean it all. So there are sometimes people will try to clean just the front. That's not going to get it done. That's actually going to confuse the ECU because it's going to have a different play on one side than the other. So what we will have to do when we clean a electronic throttle body is we need to take it all the way off and clean it from the backside. We don't want to try to shove a rag behind that throttle plate and clean it from the backside while it's still installed, because that is absolutely going to damage that throttle body. Best case scenario, it'll damage the actual spindle in the middle that holds the plate on. So we don't want to do that. It needs to be taken off. I'll talk a little bit more about that here in a second. So that's one of the most common reasons they fail. And again, they may not need an electronic throttle body at all. They may just need to clean it. We also have the opportunity where a throttle position sensor can fail. And in some cases, those are secondary located, but sometimes they're also part of the throttle body. So it may be serviceable. It may be not. You may have to replace the throttle body if that fails. And then we can have a failure of that electric motor I was just talking about, or those gear trains, right? All that little plasticky stuff that's inside. So that's one of our main 4 reasons that we're going to see a failure, and really the only reasons we would see a failure, other than some other components. Now, there can be failures of the throttle body because of a wiring fault, which could take it out, obviously, or it could just be the wire. We may have a poor connection. And then we also could have some misdiagnosis. We could have some issues with wheel speed sensors, brake switches, mass airflow sensor that could lead us to think we need an electronic throttle body, but in reality, we need something else. So it's always good if we're not 100% sure that this goes to an actual technician so that they can do a legitimate diagnosis, because nobody wants to throw a throttle body on it doesn't need one. Sometimes they can be expensive. So here's a couple of quick tips. We know what they're doing, right? We know what it does. It's opening up, it's letting air in so that all of the other things can work together. The fuel, the spark, the timing. But remember, one of the most common reasons they fail is carbon buildup. Well, again, doesn't matter how well you maintain it, you're going to get a little bit of carbon buildup, and the car knows that. So the way these are designed is over time. Let's say you have 100,000 miles on the vehicle, you're going to build up some carbon, but it's going to be very slow paced, right? As that's happening, the ECM is recognizing that the plate is either not opening like it used to or not closing like it used to by a small margin. So it compensates. It recognizes that there is a difference in the way that the plate runs. So it's going to compensate so that we don't have a running rich or a running lean condition. Now, this is why I was saying it's incredibly important to clean both sides. So let's say, for example, we pull a throttle body off and we clean it. When we put it back on, now this is whether we clean it and put it back on, or if we put a brand new unit on. In either case, after 100,000 miles, 120,000 miles, that ECM has compensated for that carbon buildup, which means when we put the new one on or the freshly cleaned one on, that plate is going to close all the way like it used to. And the ECM's compensation is not going to recognize that for many, many miles and drive cycles. So what we have to do is a relearn procedure. If we don't do that, we're either going to have low to no idle, or we're going to have extremely high idle, and it's going to confuse the person that put it on. Hey, why is it doing this? Well, it's because the ECM has compensated over time, and we need to do a relearn. In most cases, that's a manual relearn. And there's that we've done some here at the training center where you press the gas pedal 2 or 3 times, cycle the key, turn the AC on, put your left arm out the window, something like that. But there is usually a manual procedure for it. However, there are a lot of vehicles that do require a scan tool. Nissan, for example, you do have manual relearn options on those, but in some cases, you have to do it 3, 4, 5 times before it actually kicks in. So a lot of technicians will just opt for the scan tool. So there are situations like that. But remember, if you are talking to, let's say, a newer technician that hasn't worked on these a lot, or maybe a DIY customer catches you at the counter, something like that, if they get a new throttle body and they're saying, hey, this thing is idling at 1,400 RPMs, well, did you relearn the throttle body to the computer? If not, it's that simple of a fix. Another quick pro training tip here. Remember, I said there are some other things that can cause these to fail. And really, it's not a failure at all. It's just a poor connection. So if we have an intermittent fault, say we have an intermittent issue with the throttle body, what a technician can do, and most likely will do, is they'll back probe that throttle body at the pigtail, and then they'll watch it on a scope and wiggle the connectors. If while wiggling the connectors on the scope, they see a change in pattern, they know, hey, we've got a weak pattern here somewhere because we have a weak connection. And in most cases, all you need is a solvent like Stabilant 22A or another type of, pigtail, enhancer as far as contact enhancer. You put that on, problem solved. So again, we're not trying to, curb throttle body sales. We want every throttle body sale that comes through the door. But in some cases, it may just need to be cleaned, or it may just need a little bit of contact enhancer on the pigtail to the terminals of the throttle body. So there's a couple of quick tips to help you out if you get a question around high idle, low idle, or intermittent faults. So with all that said, we have to think about it this way. And I remember years ago when I was in the stores and I had my own teams, one of the things I used to tell them every day is, remember, nobody woke up this morning and said, man, I really hope my fuel pump doesn't work today. I want to go to the parts store. Nobody's ever done that. So the reality is, if a customer's coming in, it's because the ETB has failed or they think it has failed. That's when they replace them. They don't want to be there, but they have to be. So it's our job really to make sure we take care of them the right way. And in doing so, we have a few options that we can offer them when it comes to selling the right part and making sure that when they leave with that throttle body, that's the last one they're going to need. So the first option they have, obviously, we have a value line, right? There's a value line for everybody. Everybody's got a value line. You can get them online real cheap. I wouldn't recommend it though. And I'll tell you why, because on the value line, you're going to get a remanufactured throttle body. It's going to use older electronics inside of it. It will not have any updates to OE issues that we know about. And in most cases, it's not going to include the required gasket if that vehicle absolutely requires a gasket to get the job done right. So we don't want to offer them a value line part. What would be the next step? Well, we could do OE service, right? Well, that's okay. But remember, I'm going to show you here in a second quite a few, or at least two examples of where the OE got it way wrong. And this is just two of many examples. So if we sell them the OE service part, we're selling them the same design as the one that just failed. Hopefully that one had many, many miles on it. But in some cases, these throttle bodies fail very early because of the OE design. And again, we may not include the gasket in that. So we may have to call the dealer again to get the gasket. And we've all dealt with that at least once. Or you can offer them a BWD throttle body. And here's what we know they're going to get when they open that box. They're going to get a 100% new, nothing remanufactured throttle body. And it's going to have design improvements that we're going to talk about here in just a second for those applications with high OE failure rates. And in those cases where we absolutely must replace the gasket, it's going to be in the box. That's the correct option. That's the way we want to promote that to the customer and make sure they understand what's in there. And we're going to show you some more things that are in there now. So when we talk about design improvements, again, there are multiple known issue electronic throttle bodies out there crossing all makes and models. Here's a couple where we've taken quite a few measures to ensure that the customers don't have issues with them anymore. So this is another example of the Chrysler Pentastar 2-liter and 2.4-liter. I feel like we talk about those 3 or 4 times a year now. They're keeping us in business. That's what I know. But the OE problem with those is that the gear teeth will prematurely wear because it's that poor geometry I was talking about. Now, if you look at that little bubble picture in front of that little Dodge Journey, on the left-hand side, it looks like just some dirt and gunk buildup. But what that actually is a plastic gear coupled to a steel gear or a metal gear. And that's just not a great idea, right? And as you can see, it absolutely destroyed the plastic side of the gear. One, because the geometry is wrong. They don't meet up like they should. And two, again, we're going thousands of cycles. A metal gear grabbing a plastic gear eventually is going to tear it apart. So what did we do on this specific one? We fixed it. We fixed the gear and the geometry. So what we did is we actually increased the face width of the gear so that there's not as much stress on the smaller gear against the larger gear. Then we improved the geometry of the teeth, meaning we made them a little bit thicker and a little bit shorter so that when those gears match up, it's a fluid motion. There's no binding and there's no grinding there. So with this one, we have updated the most common issue, but just to make it a little bit stronger, again, I said that word plastic is not a great word to use. It's not, because what we want is at least a synthetic material in there. And that's what we did. We upgraded to a material that is much stronger than plastic. It's much more higher temp, and it's a synthetic material that will hold up. That's on this example. Well, here's another example of a very high failure rate ETB that I can remember selling 12 years ago when we first introduced this. This one's been around for a long time, and it's still a hot seller because of how many vehicles are on the road. But if you've ever worked on a GM 5.3-liter, you'll know the electronic throttle bodies are one of the highest failure rate ETBs out there. And this because of what you see on the left-hand side. It's an all plastic gear train, except for that little bitty tiny gear on the far left. So what we did is when we originally started looking at how can we fix this ETB, let's do some endurance testing. Let's try a few things. And guess what? We found out that it could barely make it 10 days on the plastic gear with an endurance test. Now, remember, an endurance test is we turn it on, we walk away, and we see how long it'll last. It's not like a normal drive cycle. 10 days is not very long. We were up to 45 days on the BWD S20006, and we shut the machine off. It wouldn't break. We could not break that. And we couldn't break it because we looked at the ETB on the GM side and said, well, here's what's wrong with it. Look at the plastic gear. So on the right-hand side, you'll see we have upgraded to all steel, and we no longer have issues with that plastic gear breaking because there's no plastic inside. And again, even after 45 days of endurance testing, this thing was still going strong. So especially with your shops that, get a lot of these 5.3s in, I can promise you they've done countless amounts of these throttle bodies. If they're not aware of what's inside of ours, they may not buy ours. But once you show them this, and we do have, things on websites and things like that, where you can actually show them this, that, hey, this is what's in ours, and this is why the ones you keep using are breaking. Go with steel, you don't have to worry about it anymore. So there's a couple of different examples of what we've done to correct the issues on some of the most high failure rate throttle bodies. And this is across the board here, right? So whether it's a high failure rate or it's a simple throttle body, when you go with a BWD, you're going to get accuracy. If there's a design improvement that's needed, like we just talked about, it'll be there. It's going to be durable. We know that because we test them vigorously. It's going to be made 100% in North America, and we're going to do some pretty wild testing on these. We do a lot of testing, and Aris is going to talk about that here in just a second. And then again, it's 100% new. We don't have to worry about any remanufactured parts or anything breaking because we threw one little cheap piece of remanufactured in there. And again, if it is a application that requires a gasket like this Pentastar motor, you'll have that gasket in the box as well. So before I pass it over to Aris, again, the bold point here with our ETB program is simple. The best parts are going to make the best parts. So we want to give you the best part in the box. And in order to do that, sometimes we're going to have to beef up and really enhance the part that goes in there. So with our program, if it requires it, you're going to see a stainless steel gear instead of plastic, or a high synthetic material versus plastic. You're going to get enclosed contact brushes. You're going to get sealed construction, so we're not going to get dirt and debris that gets in there, because that is something that can cause those gears to bind up as well. You're going to get a corrosion resistant housing, a stainless steel throttle plate shaft, which is just as important as that plate itself. And then the electric motor I alluded to earlier, those are tested from -40 to 248 degrees. Now, my sincere hope is that I will never be in either of those conditions or even half of those conditions. But let's say I had to one day, at least I know my throttle body is going to work because the motor is going to actuate the way it's supposed to. So with that, I know Miss Aris has got some great information for you. I'm going to pass it over to her. And then when she's wrapped up, I will come back and we'll finish the call up here. Aris, it's yours.
All right. Thank you, Corey. Great tips and breakdown of the tech behind electronic throttle bodies. And hello, everyone. So now let's take a quick look at the competitive landscape. I know you probably hear a lot of claims regarding coverage, but this is the real picture. BWD leads the pack with 218 SKUs and coverage of over 210 million vehicles in operation. That's more than anyone else on the board. And what does that mean for you? It means fewer special orders, fewer missed sales, and more chances to say yes to your customer immediately. We are built for this, giving you the coverage and confidence to deliver quality without hesitation. Because at the end of the day, it's not just about having more SKUs, it's about having the right SKUs, backed by quality you can trust to strengthen and grow the relationship you have with your customers, making you their #1 and preferred call every time. Building and maintaining strong relationship and keeping you as your customer's go-to call when something goes wrong is very important to us. BWD wants to make sure you got everything you need when it comes to electronic throttle bodies, and that means more than just the ETB itself. We back it up with throttle position sensors, pedal position sensors, variable intake manifold actuators, clean plug-and-play connectors. No scrambling, no callbacks, no outsourcing parts and waiting for them. Just a full solution ready to go. And because it's all built and backed by the same engineer team understands the tech inside and out, you can recommend it with confidence. Now, when it comes to throttle precision sensors, we're not cutting corners. In fact, many of these are built right alongside with electronic throttle bodies in the same high-quality facility. Inside the throttle position sensor, we got an integrated circuit that does the heavy lifting. It precisely measures throttle shaft movement and gives you that accurate linear signal you can rely on. And what really sets it apart is the magnet. It's molded into a high-performance polymer which locks it in the right spot and minimizes friction on the varying surfaces. Then we seal it up with a custom elastomer seal that keeps moisture out. And we've seen firsthand how that's a common failure point in some competitive throttle position sensor. So what's the result? A throttle position sensor that's reliable, consistent, and built to outlast the environment it lives in. Well, now let's talk about accelerator pedal position sensor, or APPS, to make it shorter. Accelerator pedal position sensors are mission critical for modern throttle control, and we make sure every single one of ours is 100% tested to deliver the most accurate signal versus the pedal position. We got over 340 SKUs in the lineup, covering 3 decades worth of vehicles, which means when that repair opportunity comes in, we likely got the solution. And what about the performance of BWD accelerator pedal position sensors? Our designs are engineered to contact with just a few grams of force, so acceleration and deceleration feel smooth and responsive. Plus, we build in high-strength dual return springs that give the pedal that confident, consistent field drivers expect every time they hit that gas. At BWD, we are proud to be one of the few true basic manufacturers of electronic throttle bodies in the North America aftermarket. Every ETB we make is calibrated and tested in-house, including output voltage validation, but we don't stop there. We go beyond the bench and into the real world with on-vehicle testing at our facility in Texas, like Corey said. That gives us a huge advantage. Many offshore suppliers simply don't have access to this wide variety of test vehicles we do, and it shows in the results. With BWD, your customer gets a part that's been through rigorous lab testing and real-world driving. When they pull it out of the box, they can install with confidence, knowing it's built to outperform the competition. And with that, I now hand things over to to Corey to show you some marketing materials. Corey?
Yeah, and thank you, Aris. I appreciate that. And yeah, so what we're going to do here is we're going to wrap it up, everybody, and just kind of give you the high level view of what we just talked about. Here's our conversation point. This is what we want to talk about when we have a technician in front of us, or really any customer that's wanting to know more about the ETB program or what ETB they should buy. Remember, ours are going to be 100% new, never remanufactured. They are designed and built by us in North America. And then we take care of those high-end issues on known OE failures, like design improvements on applications, like those geometries in the gears or adding steel gears. And then again, industry-leading coverage. There's nobody that's going to beat you on coverage, which is a beautiful thing because we have some great talking points. It wouldn't matter if we didn't have enough parts, right? Well, we do. Nobody beats us on that. And so again, we're going to take care of the customer. We're going to make sure they have everything in the box they need. It's going to be updated. And all they may need to do is a quick relearn, which they're going to be doing anyway. So, it's good to go. And you can have confidence selling them, and your technician or your customer can have confidence installing them, knowing that we have extensively tested those, not only in the lab, but on vehicles. And so to end this, I'll say, this is part of it, and there's more to it as well. We have our team out there in the field that supports you. Our sales support and training is meant for things just like this, to give you the information you need to be successful in different categories. And I sincerely hope that this will help you be much more successful in electronic throttle bodies. And hopefully here in the next 30 minutes or so, someone's going to show up and need one, and you're going to know exactly which throttle body to recommend to them. So I just double checked the Reese, and I don't see any questions on the board. So again, I'm going to tell everybody, thank you so much for being here. I hope you have a great rest of your day, and we'll see you the next time. Have a good day, everybody. Thank you, Reese.